Swayam Prabha. Digital India. Educated India.
Hello friends, so welcome to the course Introduction to Sampling Theory. So you may recall that in the earlier lectures we considered the simple random sampling, and now in this chapter also we are going to continue with the simple random sampling, but with a new perspective. You see, whenever we talked about simple random sampling, either we found an unbiased estimator or the variance, or we collected the observation, we always assumed without saying that the random variable involved is continuous. I always talked about the examples like height, weight, age on which the observations are obtained, and such variables are continuous in nature. Now, there is another issue. Suppose the random variable is not quantitative, but it is qualitative, and these things are quite possible in practice. For example, whenever you are asked the opinion on any issue, you have only two options, whether you agree or you don't agree. So, agree versus disagree. Similarly, the answer can be yes, no, true, false. Now, if you try to see, these are also observations. For example, in many marketing surveys, people simply ask, are you happy with the shopping experience? And finally, you have to give the answer in terms of yes or no. Now, if you try to think, in case if you are dealing with these types of variable, which are qualitative in nature, they cannot be quantified. For example, if I say true, false, yes, no, agree, disagree, can you really quantify them? No. But this type of data also contain important information. For example, in a marketing survey, the person really wants to know whether the shopping amenities present in the mall are satisfying the customers or not. So, the customers will be finally asked that whether you are satisfied or not, yes or no. They will give the answer in terms of yes or no. But now, how to compute it? Because for computation, you want the data in terms of some numbers, numerical values. So, the topic which now I am going to consider is that how to do the simple random sampling and related topics when the variable under consideration is qualitative. So, obviously, when the variable is qualitative, we have to devise some methodology so that it can be represented in some numbers, in some quantitative way. But definitely, the quantities cannot be like 0, 1, 2, 3, 4 with magnitude. They have to be some indicator variable. So, that is the basic idea which we are going to use. We will try to associate an indicator variable with the responses, and based on that we will try to make our calculations or the statistical analysis. So, how to get it done? That is the basic objective of this chapter, which is not really a new chapter, because we are still going to use the simple random sampling, but it is from a different perspective. Now, In this chapter, we are going to consider such a situation. But then the first question which comes to our mind is that what about the sampling scheme? So you have to remember one thing, there is no change in the sampling scheme. We are going to follow the simple random sampling. We will have two options, simple random sampling with replacement, without replacement. And we are going to follow the exact procedure in which we have drawn the random observation. So there is no change in the sampling scheme or the way we have drawn the observations. There is no problem, there is no change, that will continue to be the same. The point where we are going to start is that by assuming that now our random variable is qualitative. Based on that, we will have certain observations, and using those observations, how are we going to estimate the population mean? How are we going to find out the different type of variances, confidence interval estimation, etc.? So that is what we are going to now do, right? So now with these concepts, let us begin our lecture. So first thing I can tell you that if you want to download the slides of this lecture, then you can go to my home page, and there I have uploaded all the slides in the PDF format. From there you can download it. So the address of my home page is home.iitk.ac.in /shalab/sp. And if you have any problem in remembering this address, then you can scan this QR code also using your any application available on the phone, and this will bring you to the same address, right? And still if you feel any problem, then you can go to any of the internet search engine, and there you try to type my name and my institution name. You will see the home page over there, and then you can come to the same home page which I have shown you here. So now we are going to consider the sampling for proportions and percentages, right? And this is again based on the simple random sampling. This is what you have to keep in mind. So what are the situations where these types of things are going to occur and we are going to use? So we know that in many situations the characteristics under the study on which we try to collect the observations are qualitative in nature. For example, the responses of customers in many marketing surveys are based on replies like yes, no, or say agree, disagree, and so on. So you can see here that at this junction we are trying to consider that there are only two possible outcomes, either yes, no, or agree, disagree, or say true and false. Well, there can be more than two answers also, like a low, medium, high, something like this, but at this moment, in order to develop the concept and in order to explain you so that you can understand it well, I am going to consider the situation where there are only two possible outcomes, like yes or no, and the situation can be true, false, or say agree, disagree, and so on, right? So sometimes you will see that the surveyor asks the respondent to order the several options also, like as first choice, second choice, third choice, and so on. So in such situation, the objective of the survey is really to estimate the proportion or the percentage of the people who are lying in that category. For example, if I want to know that how many persons are there who have got a brown eyes, right? So that means we have to take a sample of the people, and then we have to check their eyes. If they are brown, answer is yes. If they are not brown, any other color, then the answer is no. Similarly, we would like to know the proportion or the percentage of the people who are not employed, who are unemployed. So what we have to do, we have to select a group of people, and then we have to ask them, are you employed, yes or no? And based on that, we would like to see what is the percent or what is the proportion of the people who are employed. So, in such situation, the first question arises that how to do the sampling, and second question is this, how to estimate the population parameters like population mean, population variance, etc. So, these are the questions which we are going to handle here. So, the first question is about how to draw the sample. So, in order to draw the sample, we are going to use the simple random sampling, and we follow the same procedure whatever was used in the case of quantitative characteristic, and using the same methodology we again draw the sample for the case when we have a qualitative characteristic. So, up to now we have done only one sampling methodology, which is simple random sampling. So, I would suggest that we follow with the same sampling methodology, simple random sampling, and then we had two cases, without replacement and with replacement. So, now we decide that we are going to use SRSWOR or SRSWR procedures for drawing the samples, whether the variable is quantitative or the quantitative. And when we have done some more sampling scheme, some more sampling methodology, then I would suggest that whatever the sampling methodology we are going to develop for a quantitative characteristic, the same methodology will be used for the qualitative characteristic also. Now, how to get it done? This I will try to explain you in this chapter, and the same concept can be used in any sampling scheme, right. So, suppose first let us try to understand the setup. So, as usual, we will have a population, and in this population there will be capital a number of units. Now, based on the characteristic under study, which is now qualitative, the entire population or the entire sampling units in the population can be divided into two groups or two classes, and those classes are say denoted by C and C star. What does this mean? Suppose I say we have a population of size 100, and there are 100, and we want to know that how many of them are agreeing to certain proposal. So, I will ask all the 100% question whose answer is in terms of yes or no. Now, suppose 70% reply answer to be yes and 30% reply the answer to be. So, now you can see here that I have divided the 100% in two groups, class C where the people are saying yes and the class C star where the people are saying no. So, this is what we mean that the population is divided into two classes, and they are indicated by C and C star. So, we also assume that the population has got capital a number of units. Out of this capital N sampling units, capital A number of sampling units belong to class C, and the remaining sampling units capital N minus capital A, they belong to the class C star, right. Just like if I try to say here, now here in this example N is equal to 100 and A is equal to here 70 and N minus A which is equal to 100 minus 70 which is equal to here, right. Now, in such cases we are more interested in estimating the population proportion or the population percentage belonging to any particular class. So, now if you agree that we are going to use the concept of proportion and we want to estimate it, the first question is how to define the proportion. So, suppose if I denote the proportion by symbol capital P, then this is defined as the total number of units in class C divided by capital N, the total population size. So, this number, the number of total unit in class C we have indicated by A. So, this is A upon N, and obviously the proportion of such units in class C star will simply become the total number of units in the class C star, which is here N minus A, divided by total number of total number of units, which is here capital N, and this is indicated by the parameter capital Q. So, the population proportion for the class C is indicated by capital P, and the population proportion of class C star is indicated by capital Q. And if you try to see the structure of capital Q, this is nothing but your 1 minus A upon N, and A upon N is your capital P. So, Q is equal to 1 minus P. So, P plus Q will always be equal to 1, that is obvious, right. So, this is the structure of my population. Now, I have to draw a sample. So, up to now we have done only the simple random sampling. So, we know only one sampling scheme, that is simple random sampling, and that can be with replacement or without a replacement. So, now you can see here that we have the same setup, that we have a population of size capital N, which is divided into two classes, class C and class C star. Class C have capital N number of units, and class C star has N minus N number of units. Now what I do, I try to draw a sample of size small n units from this population. Now, obviously, this sample will also contain the units having the characteristic or not having the characteristics. For example, if you try to take here the same example, from this 100 persons, I try to take here a sample of say 40 persons. So, now n is equal to here 40. Now, out of this 40 persons, there will be some person from the class C and the remaining persons from C star. So, it is possible that out of these 40 persons, there are 25 persons who are saying yes, and there are 40 minus 25 is equal to 15 persons which are saying no to the proposal. So, essentially I can say here that we had a population of size 100, from there I have drawn a sample of size 40. In the population there were 70 persons in the class C and 30% in the class C star, but in the sample there are only 25% in the class C and 15% from the class C star. So, essentially I can say that that when I am trying to draw the sample from the population of size 100 and we have drawn a sample of size 40, this is equivalent to say that I have drawn a sample of size 25 from this class C, and we have drawn a sample of size 15 from class C star, right. So, this is exactly the same thing which I am trying to indicate here. So, now we have drawn here a sample of size small n from a population of size capital N, and when we try to count the sampling units in this small n number of units, we find that there are small a number of units which are coming from the class C, and obviously there will be small n minus a number of units which will be coming from the class C star, right. This is going to be our sampling procedure. So, you can see here this is the same what we have done in the case of simple random sampling. So, when I am saying that you are going to draw a small n number of units from the capital N number of units, you have to follow the same procedure of simple random sampling, that you are going to draw all the units one by one, and then that will be your decision whether you want to use the simple random sampling without replacement or simple random sampling with replacement. Although now we know that in case if you are interested in estimating the sample mean, then simple random sampling without replacement will give you more efficient result. But here I am not talking of those things. Here I am simply trying to illustrate how you are going to obtain a sample. I hope it is now clear. Right. So, now exactly on the same way as we had defined here capital P and capital Q for the population, the proportions of unit in class C and class C star in the population, similarly I have to, or we need to define the similar quantities for the sample also. So, now we have got here a sample of size small n, and in this sample there are small a number of units which are belonging to class C, and there are n minus a number of units which are belonging to the class C star, right. And now in case if you try to find out the proportion of the units belonging to class C or C star out of the sample, then I can say that the sample proportion of the class C is given by, say, number of units in the class, which is here A, divided by total number of units, which is here small n. So, this proportion can be indicated by small p is equal to small a upon small n. So, this small p is going to indicate the sample proportion and capital P is going to indicate the population proportion. And exactly in the same way we have defined the capital Q, here also we can define the small q. So, small q is the proportion of the units in the class C star. So, there are small n minus a units in this class, and they have been drawn from the total number of small n number of units. So, this proportion will become n minus a upon n, which is equal to 1 minus a upon n, and which is the same as 1 minus small p. So, once again you can see here that small p plus small q is equal to 1, right. Okay. Now, I try to give you here one more example to make you understand. Suppose I have here a population of 10 units, and this population has been collected in the following way, that there was a coffee shop, and that coffee shop had offered a new flavor to 10 customers, and after that they asked how is the taste. So, some of the customers became extremely happy with the taste, and there were some customers which were not happy with the taste. So, that is how I have denoted here by this yellow smileys. I am indicating the happy faces, and with this red sad smileys I am indicating the reaction of those customers which were not happy. So, you can see here there are 1, 2, 3, 4, 5, 6 yellow faces, and there are 4 sad faces which are in red color. So, now you can see here I have 2 categories, happy and sad. So, I can divide the entire population into 2 classes, one class which is for the happy customers and another class which is for the sad customers. So, you can see here now this class 6 has 6 units and class C star has 4 units. Now, I try to draw here a sample of size 5, and suppose in the sample I obtain 1, 2 and 3 happy faces and 1 and 2 here sad faces. So, now in this sample also I can divide all these smileys into 2 groups, happy faces and sad faces. So, now if you try to look on these 3 happy faces and these 2 sad faces, don't you think that it looks like as if I have drawn a sample of size 3 from this population of 6 units in class C? And if you try to look on this these 2 sad faces, don't you think that it looks like as if I have drawn here a sample of size 2 from the class C star containing the 4 units? And yes, obviously, if you ask me from population to sample how I have drawn the units, I will say simply that is your choice, either you want to use SRSWOR or SRSWR, whatever you want. So, this is what I mean by this setup which I am trying to explain you here. So, now after this example, I try to make it more formal using the symbols and notations. So, as usual, I will take capital N to be the population size. And now I am taking here capital X to be a qualitative characteristics which we want to study. So, since this is qualitative, so we assume that there are only two possible classes, and those classes are mutually exclusive. That means there should not be any unit which is belonging to both the classes. Although that was clear from the examples which you have taken, the way we have constructed capital P and capital Q, right. So, these classes are indicated by C and C star. So, these are two mutually exclusive classes. Now, if I try to take an example of this X, C and C star, for example, if X is the opinion of persons on a proposal as we discussed, then C is the part of the population of persons saying yes or they are agreeing with the proposal. Then obviously, the remaining persons we are assuming that they are not agreed with the proposal. So, that class is going to be indicated by C star. So, C star is the part of population of persons saying no or they are not agreeing with the proposal, right. Similarly, if I take another example, if X is the gender of students in a college, something like male and female, then C is the part of the population consisting of male students, then obviously the C star will become the part of the population consisting of female students. So, this is how we try to create these classes, right. Now, as we have discussed earlier, now we discuss in a more formal way, we assume that let there be capital A number of sampling units in the class C. So, obviously, the remaining units will belong to the class C star and such type of units will be capital N minus capital A. So, the total number of units in the class C star in the population of size N will be capital N minus A. Now, since these characteristics are qualitative, so we would like to study the proportion or percentage. You know, once you know the proportion, you can also compute the percentage. So, there is no difference between the two as far as the concept is concerned, right. So, the proportion of units in the class C will become the total number of units in the class C, which is here A, divided by the total number of units in the population, which is A upon capital N, and this will be indicated by capital P. So, capital P is going to indicate the population proportion of the characteristic. Now, obviously, what will be the proportion in the class C star? So, that is going to be the total number of units in the class C star N minus A divided by the total population size capital N. So, now this is going to be indicated by capital Q. So, this capital Q is going to be 1 minus A upon N, which will be equal to 1 minus capital P, right. So, obviously, if you try to see what are your capital P and capital Q, for example, capital P it can be the population proportion of persons saying yes or agreeing with the proposal, and capital Q will be the population proportion of persons saying no or disagreeing with the proposal, right. And now, we have drawn a sample of size small n from the population of size capital N by simple random sampling. Then we expect that in the sample there will be elements from both the groups C and C star. So, let small a be the number of sampling units in the sample which falls into the class C, and the remaining units which are small n minus small a, these are the number of units which falls in class C star. Now, we can compute the sample proportion of the units in class C and class C star. So, the sample proportion of units in class C will become the total number of units in the class C in the sample, which is small a divided by total sample size, small n, and this is going to be indicated by small p. And obviously, the sample proportion of the units in the class C star will be the total number of units in the class C star divided by the total units in the sample, which is small n. So, obviously, this becomes here 1 minus a upon n, and small a upon n is small p. So, now this proportion is indicated by small q. So, now we have here population proportion capital P, and the sample proportion is indicated by a small alphabet letter p, and capital Q is indicating the proportion of unit in the class C star, and small q is indicating the proportion of the units in the sample which are belonging to the class C star. That is now we have to keep in mind. Right. Okay. So, now up to now, if you see, we have considered a qualitative characteristics whose responses are going to be something like yes, no, agree, disagree, true, false, etc. But definitely using these observations we cannot do any statistical analysis. For the statistical analysis we need the numbers. So, now one possible solution to handle such a situation where we have got the observation in terms of yes, no, agree, disagree is that we can associate an indicator variable with the characteristic under study. So, up to now remember we have taken the capital X to be the characteristic. Now, we define an indicator variable which is indicated by capital Y, and we try to associate it with the characteristic under study capital X. And then this indicator variable Y takes value capital Yi equal to 1 or 0 depending on whether the ith unit belongs to group C or C star. So, Yi takes value 1 if the ith unit belongs to C, and Yi takes value 0 if the ith unit belongs to the class C star. Now, whatever observations you had, for example, you had observation something like yes, no, yes, yes, no. Now, they will be converted into 1 and 0. For example, if I say for yes we are using here 1 and for no we are using 0. So, this will become yes, yes 1, no for 0. So, the data will now look like 1 0 1 1 0. Now, you see, now you have converted the qualitative characteristic into a quantitative variable on which you have got the observation in terms of 0 and 1. Right. Well, I am not saying that 0 and 1 are the only possibilities. You can take any other value, but you will completely agree with me that in case if we are trying to take 0 and 1, then the interpretation of the results will become simpler, and that you will see in the forthcoming slides also. Now, in case if you try to recall, when we had considered the simple random sampling, we had considered the estimation of population mean and population total, and we had proposed the arithmetic mean of the sample observation as an estimator for the population mean, and the population mean was also indicated by the arithmetic mean of all the population units. So, the same thing will happen, or I would say the same thing we would like to consider in the case when we have a qualitative characteristic. For example, if you try to see the population total, we had earlier denoted by YT or Y total, I can say. This is simply I goes from 1 to capital N Yi, capital Yi. So, if you try to see what is this summation Yi, summation Yi will be taking the value 1 plus 0 plus 0 plus 1 and so on. For example, if you try to take here this case, suppose this is your population, this is going to be here 1 plus 0 plus 1 plus 1 plus 0. So, that is equal to here 3, And if you try to see, there are 3% in the population who are saying yes. So these are the people, or this is the number of people who belong to the class C. So in case if you try to think, we are assuming that there are capital A number of elements in the class C, or there are capital A number of sampling units in the class C. So this Y total will become simply capital A. And earlier you had defined the population mean also. So this population mean capital Y bar was defined as I goes from 1 to capital N yi, summation I goes from 1 to capital N yi divided by capital N. So now if you try to write down the same statement under the given setup, then summation I goes from 1 to N yi is your A divided by capital N. So A upon capital N is nothing but your capital P, which is the population proportion. And similarly, since you have used the simple random sampling, so the first attempt will be to estimate the population mean by the sample mean. So the sample mean small y bar was defined as summation I goes from 1 to small n yi divided by small n. So now this I goes from 1 to n yi will also be the sum of 1 plus 0 plus and so on up to n terms. So obviously, when you try to add such a quantity, only the number of ones will appear, and you have assumed that there are a number of sampling units in the sample which are coming from class C. So this proportion will become A upon small n, and which is nothing in your but in your symbol this is simply small p. This is the sample proportion. So now if you try to see, you have done a very important job. You have found a relationship between the population total mean and sample mean of a quantitative characteristic in terms of qualitative characteristic. The population total is simply A, population mean is something like P, sample mean is something like a small p. Now, can you think what will be the advantage? Right, if you keep on thinking, and I will try to complete. Tell me one thing, when I am trying to devise this or define yi as 1 or 0, if ith unit belongs to C and if ith unit belongs to C star, then we have found that I goes from 1 to capital and yi is nothing but your A, because that is something like 1 plus 0 up to say here capital N terms. But if I ask you what will happen to I goes from 1 to n yi square, so obviously this will be a quantity like 1 square plus 0 square up to so on, and this will be your here total n terms. So what will be the sum of these number? 1 square is 1, 0 square is 0, and so on. So this number is again going to be capital A. Right. So this I goes from 1 to capital N yi square will be the same as capital A, and you have defined this A to be something like as if P is equal to A upon N. So this A will become the same as NP. Now, once I have written summation yi square as A, I have written summation yi as A, I have written capital Y bar as P, don't you think that we can also write the quantity capital S square in terms of capital P and capital Q? Why not? Let us try to see. If you remember, your capital S square was defined as 1 upon capital N minus 1, summation I goes from 1 to capital N yi minus y bar whole square. And if you try to open this square bracket, this will become 1 upon capital N minus 1, summation I goes from 1 to n yi square minus n times y bar whole square. Now, if you try to substitute all these values, this summation yi square will become here np, and y bar here is p, so y bar square will become here p square. So, now you can see here this quantity becomes here 1 upon n minus 1, n comes out, p comes here out, then I have here 1 minus p. So, you can see here, and this quantity here is q. So, this quantity becomes here n upon n minus 1 p q. Now, you see what I have done. Exactly on the same line, you can also define the small s square also. So, this I goes from 1 to n yi square for the sample will again be your here a, which will be say here np, because once again you have, if you remember, you have done summation yi is equal to a, and summation yi square will be something like 1 square plus 0 square up to here n terms. So, that will again be equal to a, right, and this will be the same as here np, because you have defined the sample proportion to be a upon n, right. So, now if you try to express this small s square, this will be 1 over n minus 1 summation I goes from 1 to small n yi minus y bar whole square, and if you try to open it, this will come out to be summation yi square minus n times y bar square. Now, summation yi square is nothing but you have obtained as np small n small p, and this y bar is a small p. So, y bar square becomes p square, and whole this quantity becomes here, if you try to take np outside the bracket, this becomes here 1 minus p, and 1 minus p is nothing but your small q. So, this quantity is now expressed as n upon n minus 1 times pq, all in small letters, that is based on the sample values. Okay. Now, if you try to see what you have done, I am just trying to just write all the things in a single slide, so that I can explain you in a much better way. You have obtained the value of capital Y bar, which is coming out to be same as capital P. You have obtained the value of Q, which is 1 minus P, which you have obtained the value of capital S square, which is coming in terms of n upon n minus 1 PQ for the population. Now, for the sample, the same thing, the sample proportion is the same as Y bar. Small q is equal to 1 minus p, small s square is equal to n upon n minus 1 times p q. Now, looking at this slide, can you really understand what I want to say? Here you can see you have shown the connection between the quantities like population mean, sample mean, population variance, sample variance, and the connection is between the two types of variable, when they are qualitative and when they are quantitative. So, now my question to you all is that we already have proved, discussed the properties under simple random sampling for the quantitative characteristics. We have proved that expected value of small y bar is equal to capital Y bar, means as long as you have drawn the sampling units using the simple random sampling. So, here also in the case of proportion, you have drawn the sampling units only by simple random sampling. So, now if I can say that small y bar, which is the sample mean, is an unbiased estimator of population mean capital Y bar, don't you think that I can say directly here that I try to replace this small y bar by p, small p sample proportion, and capital Y bar by capital P population proportion. And can I say that sample proportion is also and unbiased estimator of the population proportion, right. Now, I have here two options. Either I try to start from scratch, as I did in the case of simple random sampling, and I try to establish all such properties like its unbiasedness, variance, its estimator, etc. once again for the qualitative characteristic. Or I try to use this type of relationship between the two types of variables, quantitative versus qualitative, and I try to do my algebra, do my results using these results directly instead of proving them by basic fundamental. Yes, I think this is a more intelligent way. So now you can note down here that we have expressed these quantities small y bar, capital Y bar, small s square, capital S square as a function of only sample and population proportion, small p, small q, capital Q, and capital Q. And since the sample has been drawn only by simple random sampling and the sample proportion is the same as the sample mean, so the properties of sample proportion in SRSWR and SRSWR can be derived using the properties of sample mean directly. This is what I was trying to establish up to now, right. So now before I try to go further, let me try to show you that what is the meaning what I am trying to say it, and means how one can see that there is a one-to-one relationship between the methodologies when the variable is quantitative and when the variable is an indicator variable. For example, suppose if I say I have a population in which I try to compute the capital Y bar as summation I goes from 1 to capital N yi divided by capital N. So obviously in this case we have defined our random variables to take only two possible values, 1 and 0 when the ith unit belongs to C and when the ith unit belongs to C star or it does not belong to C. So this sum is going to be like 1 plus 0 plus 1 up to all the observations which are either 0 or 1 divided by capital N. And if you try to add here all the term 1 plus 1 plus 1, so you know that this is going to be capital A number of time. That is what we have assumed. So A upon N is going to be here capital P. And now on the other hand, now similarly if you try to find out here the value of summation I goes from 1 to capital N yi square divided by N. So you can see here this will become something like 1 will become 1 square, 0 will become 0 square, 1 will become 1 square, and similarly the last 0 and 1 will also become 0 square 1 square divided by N. This will again be your here 1 plus 0 plus 1 up to here 0 plus 1 which will be divided by here N, which will be again has here A upon N, which is here capital P. And once you have obtained the capital P, you can obtain the capital Q also as 1 minus P. Now I try to do the same thing for the sample also. So for the sample mean is going to be summation I goes from 1 to small n, small yi divided by small n. So now again the values in the sample they are also going to take the similar value 1 plus 0 plus 1 and so on. So these are all together n values, and out of which 1 values are altogether a values and 0 will be n minus a values. So now in case if you try to sum 1 plus 0 plus 1 plus 1, this will be 1 8 times. So this will become here A upon N, and that is the same as here small p. And similarly if you try to take here I goes from 1 to N yi square divided by N, that will also become means all 1 and 0s will be replaced by 1 square and Greek square, and you will get here the same thing A upon N, which is the same as here small p, right. And obviously then you can obtain here this Q here as a 1 minus small p. So this is the relationship. Now Today I will try to show you the final result for which I was working up to now, and I will try to give you the proof of these results in the next lecture. So, in the case of simple random sampling, we have learned that we found that sample mean is used to estimate the population mean, and so now in case we want to estimate the population proportion, so once again I can use the sample mean, which is the same as the sample proportion. So, we propose here that we try to estimate the population proportion by the sample mean small y bar, which we have seen that this is the same as a small p, which is equal to I goes from 1 to small n y I divided by n, and this will come out to be the same as here a upon small n. Right. And now we have seen that the sample mean remains the unbiased estimator of population mean in simple random sampling with and without replacement both the cases. So, the same result will continue here also, that the sample proportion is an unbiased estimator of the population proportion in both the cases, simple random sampling without replacement and with replacement. And if you remember, we had obtained the variance of y bar sample mean as say n minus n upon n n s square bar, and it was n minus 1 upon n n s square in the case of w r. So, now what I have to do, we already have found the value of capital S square in terms of p and q, you can see here, right. This is here the value of capital S square in terms of population proportion. So, now what I have to do, I simply have to replace this capital S square by here n upon n minus 1 times p q. And if I try to do it, then the variance of the sample proportion in case of simple random sampling without replacement will come out to be capital N minus small n into capital P capital Q divided by capital N minus 1 into small n. And in case the sample is drawn by simple random sampling with replacement, then this variance of sample proportion will come out to be simply capital P capital Q upon small n. So, this is the final result what we will get, right. And now obviously you can see here that capital P and capital Q, these are the population values which are unknown to us, and if you are working on the basis of a sample you cannot estimate them, right. So, you would like to estimate it. So, you had seen that earlier that you had found that expected value of S square is equal to capital S square or sigma square, depending on whether you are using simple random sampling without replacement or with replacement. So, we have already found the value of small S square, you can see here in terms of sample proportion. So, now what we can do, that we can simply replace the values of small S square in the case of variance of y bar like n minus n upon n n S square, this will be replaced by small S square, this will become an estimator, and then this S square can be replaced as a function of P and Q. So, if you try to do it, you can obtain an unbiased estimator of the variance of sample proportion under without replacement case like this one, capital N minus n upon capital N into small n minus 1 into P Q, and in case of simple random sampling with replacement, this estimator of variance will become small p q divided by small n minus 1. And if you want to find out the standard error, then you simply have to take the positive square root of this variance or the estimated variance actually. So, on the next time I will try to give you the derivation of these results, and in this lecture now we stop here. So, you can see that in this lecture what we have done, we have developed the setup for handling the qualitative statistic. And what we have done? We have considered the setup what we had developed in the simple random sampling for a quantitative variable. For example, we consider the sample mean as an estimator of population mean and we derive its properties. So, now we have established a connection of the quantities and tools that we developed in the case of simple random sampling for quantitative variable with the qualitative variable. My sampling scheme remains the same, and based on that we are trying to now explore that how one can estimate the population proportion, population percentages, and that will itself be a random variable. So, then what will be its standard error variance. So, today I have given you the final expressions, and in the next lecture I will try to give you the proof so that you can be more confident. So, you try to think about it, try to practice it, try to revise the lecture, and I will see you in the next lecture. Till then, goodbye.